Have you ever, run into that really frustrating attitude in tech? The one that kind of suggests, oh, because you know the older stuff, you just can't possibly get the new tech. It feels pretty common and maybe a bit unfair sometimes. But is there any truth to it? Or is it just, well, a myth? Today we're doing a deep dive to really tackle that idea head on. Our mission is to explore how graphical user interfaces, GUIs, how they've evolved. We're really focusing on this big shift from what I call imperative programming to the newer declarative ways of doing things. And I think as we unpack it, we'll see how your experience, the stuff you already know isn't a drawback. It's actually a huge asset. We've got some great sources lined up. There's a solid technical piece that really debunks that whole experience is bad idea. Plus a discussion on like user preference versus the tech itself and a really detailed comparison of these different GUI approaches. And it's all kind of framed around building something pretty relevant right now. It's an NLO2 SQL project, natural language to SQL.
That's right. We're going to get into the core ideas behind building interactive software. And what you'll see is that these fundamental concepts, they really connect the dots between the old and the new. It shows that understanding software design, being adaptable, that's what really matters for a developer.
Okay, so let's dig into that. This big split imperative versus declarative GUIs. What's the actual core difference in how you program them?
The main thing really is how you're talking to the computer. With imperative, you're giving very specific step-by-step instructions like do this, then do that to build and change the UI. Declarative, on the other hand, is more about describing what you want the UI to look like based on the data you have right now. And then the framework itself figures out how to make that happen.
Okay, so for the older GUIs, maybe like Tkinter or Swing, you're saying it's like being an architect who has to place every single brick manually and tell the builders exactly what to do if anything changes.
Exactly. That's a great way to put it. You create the button, you add it to the layout, you write a specific function, a callback for what happens when it's clicked. And crucially, if the data changes, you have to write code to go find the label or the text box and update it yourself. Manually. It gives you lots of control, sure, but in anything complex, it gets tangled really, really fast. You're juggling all these state updates yourself.
Right, and this is where the newer tools, Panel, Streamlit, Dash, they really change the game. Yeah. How do they flip that script?
They totally embrace this declarative idea, often using what's called a reactive style. The core of it is this reactive data flow. Instead of manual commands, you basically say this part of the UI depends on this piece of data. So if that data changes, maybe text input, a slider moves anything connected to it, automatically reruns or reevaluates. The UI updates itself to match the new state. You, the developer, you don't manually manage those updates. The framework handles it. It's kind of like an Excel spreadsheet, right?
Yeah.
You change a cell, and all the formulas that depend on it just recalculate instantly. You declare the relationships.
That spreadsheet analogy really clicks. Can you pull an example from the sources, maybe using Python, to show this difference in action?
Oh, definitely. The sources have a good side-by-side. Let's imagine a simple app. Type text in, process it, show the result. Okay, old school, imperative, maybe Tkinter. You'd have code where a function explicitly calls get on the input box. Then it takes that value and manually calls config on the output label to set its text. Step 1, step 2, get input, set output. Very direct. Now contrast that with the new way, declarative, using panel. You'd use something like a decorator, maybe a pn.depends, or a function like pn.bind. You're just stating that the output function depends on the input widget's value. That's it. Panel sees that dependency. When the input changes, panel automatically runs your function and updates the output display. No manual config call from you.
Wow, okay, so you're not writing the update logic, just defining the relationship.
Exactly. It's a huge shift in responsibility.
So what does that actually mean for the developer sitting down to write code? How does it change the day-to-day?
Oh, it's a massive difference. This move to declarative makes things way, way easier and faster, especially for data-heavy apps like that NL2 SQL example. We're not talking small improvements here. It can literally change how long it takes to build something complex. Weeks down to days, maybe even hours for prototypes. A few big advantages jump out. First, state management. In the old imperative world, keeping track of every little piece of state, what's in this box, is that button enabled that was all on you. And it's where tons of bugs creep in. With declarative frameworks, the state is often just part of the components themselves. The framework handles keeping everything in sync. It's a huge mental load off your shoulders.
I can imagine. Less bookkeeping.
Definitely. Then there's integrating with backend services. Think about NL2 SQL. You send off the user's sentence, and it might take, seconds to get the SQL back. In a traditional GUI, that call would just freeze the entire interface. total lockup. The only way around it was diving into manual, complex threading code just to keep the UI alive. It was a real headache.
Right, the dreaded frozen window.
Exactly. Modern frameworks are often built to handle that kind of asynchronous stuff much more elegantly, sometimes almost automatically. And maybe the biggest thing is it just reduces complexity. Less boilerplate. You write less code overall, and the code you do write often makes more sense because it's describing the data flow, not just a long list of commands.
Okay, so it sounds way more efficient. But let's circle back to that initial idea of the experienced developer. The sources say the claim that old-school GUI folks can't learn this new stuff is technically unfounded. Why is that just wrong?
Well, it's fascinating because the fundamental ideas behind building good software, good UIs, they don't really change that much. They're transferable. Someone who really gets imperative programming, who understands event loops, state, how UI elements work under the hood, they actually have a fantastic foundation. Knowing the problems that declarative approaches solve makes it easier to grasp why they work the way they do. That context is gold.
Ah, so it's not like throwing everything out. It's building on top of that understanding, and evolution, not a replacement.
Precisely. These sources had a great analogy moving from a manual car to an automatic.
Right.
You still need to know how to steer, brake, follow the rules of the road. The core driving skills are the same. The automatic just handles the gear shifting for you, making it simpler to operate. A good software engineer adapts. Learning new tools, new paradigms, that's just part of the job, right? It's a core skill.
Okay, that makes a lot of sense. So we see the philosophical split. Let's get into the nitty-gritty comparison from the sources. How do these paradigms really differ across different aspects?
Okay, let's break it down point by point based on the analysis. Core principle. Imperative is direct, manual UI manipulation. Declarative is describing UI as a function of state.
Got it.
State management. Manual and explicit for imperative. Automated, framework managed for declarative. Big difference there.
It's huge.
Data flow. Imperative can be all over the place, often complex multidirectional flows. Declarative usually pushes for a cleaner, unidirectional flow. Easier to reason about. Asynchronicity. This is a big one. Imperative. You're wrestling with threads, queues, locks, all manual. Declarative often gives you higher-level ways to handle async, manage loading states, often built right in.
Much less painful, sounds like.
Oh, yeah. UI layout. Imperative can sometimes be simpler for very basic things, but often mixes layout and logic. Declarative pushes component-based design, separating concerns much better. Modular.
Components.
And frameworks, yeah.
Frameworks. Think Tkinter, Swing, maybe PyGTK for imperative. For declarative, you've got Panel, React, Vue, Streamlit, Svelte. Lots of modern choices.
And where would you use each?
Applications. Imperative is still fine for maybe small, simple desktop tools. Declarative really shines for complex web apps, data dashboards, interactive prototypes, anything data-driven and potentially complex.
That paints a really clear picture. But what about actually writing the code? Is one just flat out easier than the other? Or does it vary?
It really does depend on the specific task, and yeah, your background plays a role. The sources kind of broke this down too. For UI layout, declarative generally makes it simpler. Building UIs out of reusable components, that usually leads to cleaner code, separates how it looks from how it works.
Okay. What about making things interactive, clicking buttons, etc.?
Interaction. Imperative needs those explicit callbacks for everything. Click this, run that function. Declarative frameworks like Panel often let you just bind things together, like pnn.bind says, link this function's output to this widget based on these inputs. More descriptive.
Less wiring, more connecting.
Exactly. State management. We talked about this imperative is error-prone, manual tracking. Declarative lets the framework handle it. Now, the concept of declarative state, like unidirectional flow, might take a moment to click initially, but once it does, it's usually much easier.
Right, a bit of a learning curve maybe, but less error-prone day-to-day. What about debugging?
Debugging. Imperative code can be easier to step through line by line. Declarative sometimes feels a bit like magic because updates happen automatically. Tracing exactly why something updated can sometimes be trickier, though good tools and patterns help a lot.
And the async stuff again.
Asynchronous processes. Imperative means manual threads, queues, locks complex, easy to get wrong. Declarative often provides built-in, abstract ways to handle it, makes long-running tasks feel almost trivial sometimes. The framework takes the strain.
Looking at all that, it feels like for the kinds of things many listeners might be building dashboards, data apps declarative seems to have a strong edge.
Undeniably, yes. For those kinds of applications, declarative tools like Panel are just superior. You can build prototypes incredibly fast, often with surprisingly little code. Lets you focus on the data, the logic, not fighting the UI toolkit.
And you mentioned there are flavors even within declarative,
Yeah.
like panel versus streamlit.
Yes, that's a really important nuance the sources bring up. Streamlit is often seen as the iPhone, super simple, very easy to get started. It often achieves this simplicity by rerunning your whole script when almost anything changes. Great for quick things, but maybe less efficient for really complex apps.
Okay.
Panel is maybe more like the Android in that analogy. It gives you more fine-grained control, more customization options. For something complex, especially with long background tasks like our NL2 SQL example, Panel's reactive model, where it only recalculates what actually needs to change, is generally much more efficient and scalable.
Gotcha. Let's dive deeper into that critical piece,
Yeah.
handling those long-running tasks smoothly. That NL2 SQL query taking time is a perfect case. How do these different approaches keep the user happy, or at least informed during that wait?
Yeah, this is absolutely crucial for user experience. Nobody wants a frozen app. The UI needs to stay alive, maybe show a spin or give some feedback. So the old model, imperative. If you just make that network call directly, boom, UI freezes. The event loop is blocked, dead stop.
Yeah.
The only way out was that manual threading. You push the work onto a background thread, but then you need complex stuff like queues or other mechanisms just to safely get the result back to the UI thread to display it. It's fiddly, error-prone, just messy.
Definitely sounds like a headache.
Now, the new model, declarative, it tackles this at a higher level. Remember that panel example code, pn.panel, interactive conversation, loading indicator, true?
Right, just adding that loading indicator.
Exactly. You're not writing thread code. You're not setting up queues. You're just declaring a desired property. Show a loading indicator while this thing is busy. The framework panel, in this case, understands this. It handles running the task asynchronously, keeping the UI responsive, and hiding that indicator for you. All that complexity is abstracted away.
That shift from telling it how to handle waiting to just describing that it should show it's waiting, that sounds like a massive win for UX, not just the developer.
It absolutely is. It directly ties into fundamental UX principles. Think about visibility of system status. Giving that immediate feedback, like the loading indicator, is key. Declarative tools make this almost trivial, whereas in imperative, it was extra work you had to remember to do.
Makes sense. Keeps the user in the loop.
Exactly. And then there's consistency in standards. Because you're building UIs from these reusable component standard buttons, standard inputs, it's much easier to get a consistent look and feel. Your app feels more polished, more intuitive.
Right, less chance of inventing slightly different buttons everywhere.
Precisely. And finally, think about the cognitive load on the developer. By automating state synchronization, by handling async complexity, these frameworks free up so much mental energy. You can focus on the actual problem you're trying to solve, the business logic, not the plumbing. That generally leads to better, cleaner, more maintainable code.
Okay, so pulling all this together, what's the final verdict for our listener? If they're starting a new project, how should they choose?
Well, the trend is pretty clear from the comparison. GUI development has definitely shifted towards declarative, state-driven approaches. Imperative frameworks like Tkinter, they still work. They're okay for very simple, small desktop things, maybe where you don't have much interaction or background processing. You're often built in, easy to start with.
Sure, for basic tools maybe.
But for anything more modern, especially data-driven apps, dashboards, web UIs, declarative frameworks like Panel, Streamlit, PyQt, which has declarative aspects too, React, Vue, they are generally the way to go. They handle so much complexity for you, letting you be more productive and focus on the important stuff. And specifically for that NL2 SQL kind of project, Panel really seems like a sweet spot. It handles that core challenge, the long-running, non-blocking tasks so elegantly without forcing you into manual threading hell. So yeah, for data-heavy projects needing flexibility, Panel's a strong recommendation.
So after hearing all this, what really sticks out to you listening in? For me, it's reinforcement that tech evolution isn't always about throwing out the old. It's often about building smarter layers on top, abstracting the tricky bits away.
I agree. This shift isn't just a flavor of the month. It feels like a natural progression in software design, really doubling down on good old principles like separating your data from how you display it. It's about managing complexity better.
And that line, good computer scientists adapt. It's not just a nice phrase, right? It really rings true here. So for you, the listener, getting your head around this imperative to declarative shift isn't just about learning a new library syntax. It's about grasping the mindset behind building modern, scalable, user-friendly applications.
Exactly. And maybe the final thought to leave you with is this. Now that the framework is handling more of the low-level how, what new possibilities open up for the what? What kinds of complex problems or innovative interfaces can you build now, precisely because those underlying mechanics have been made simpler for you? What becomes possible when that complexity is abstracted away?